Welcome to the tutorial over 1/6 solving compound and absolute value inequalities. Our new vocabulary is going to be compound inequality, intersection, and union. A compound inequality consists of two inequalities joined by the word and or the word or. And to solve one of these inequalities, you must solve each part of it. Okay? And the graph of it, a compound inequality containing the word and, is the intersection of the solution sets of two inequalities. And the graph of a compound inequality containing the word or is the union. So the first thing we're going to talk about is the and compound inequalities. So if you take a look at the words here for the key concept, a compound inequality containing the word and is true if and only if both inequalities are true. So the example we have here, x is greater than or equal to -4. And to the right, we went ahead and graphed greater than or equal to -4. Now remember, the line underneath means that we're going to have a closed circle, and we're going to shade to the right because anything better than greater than -4. If we took a look at the second inequality, x is strictly less than 3. Now, we go to the number line, we look at 3, we put an open circle because there's no line underneath the inequality, and we shade to the left because we want numbers that are less than 3. Now, to get the intersection, okay, we have one endpoint here at 4 with a closed circle, and we have one endpoint here at 3 with an open circle. And you can tell that we are shading towards each other, okay? So all my answers are going to be shaded between these 2 points. This is for an and compound inequality. It's very important. You know that you're shading it in between your endpoints. Here in a minute, we're going to be shading the opposite directions with the or. So let's try an example. Example 1. Solve 10. That's missing a sign here. That's supposed to be 10 is less than or equal to 3y minus 2 is less than 19. And we're going to graph the solution set on a number line. Now there's two different methods we can use. I'm going to show you the first method and then the second method. So the first method, we solve the inequality separately. So what you can do is you can write this as 10 is less than or equal to 3y minus 2. And then instead, we're going to separate this by putting an and. We're going to rewrite the middle term, 3y minus 2 is less than 19. Okay? So essentially we just split this part, and we're going to solve these separately. Looking at the first one, we need to add 2 to both sides. That's going to give us 12 is less than or equal to 3y. And then we're going to divide by 3. To get 4 is less than or equal to y. And then in this case, since we did not divide by a negative, we do not have to flip our sign. Alright, let's look at the other side. We're going to add 2 to both sides. We get 3y is less than 21. We're going to divide by 3 on both sides to get y is less than 7. Now remember, we did not divide by a negative number, so we can keep it like that. Now we can put our inequality back together. 4 is less than or equal to y is less than 7. Before we graph it, I want to go ahead and show you the second method to solving these. Okay? You can actually solve these both together. So go ahead and rewrite your inequality. And this time we're not separating it with an and. Okay? So we want to get y by itself. So we're going to add 2 in all 3 places. Okay? So here we get 10 plus 2 is 12 is less than, the 2's go away, so we have 3y is less than 19 plus 2 is 21. And our last step is, since we want y by itself, we're going to divide everything by 3. 12 divided by 3 is 4. 3 divided by 3 is 1, so we're left with a y is less than 7. So it's a little bit less steps, but if you get confused easily, you can always separate it out if that helps you. And our last step is going to be to graph this. So what I would do is I would just go ahead and draw a number line. Now, if you like the example in the very beginning where you graph each of them separately and that helps you, go for it. Or you can just put it all on one number line. I know that my endpoints are going to be 4 and 7. Okay, so I'm going to take a look at my signs. I know that y can actually be equal to 4, so I know there's going to be a closed circle at 4. And I know that y is greater than 4, so I know I'm going to have to shade this way. I'm just going to put a little arrow there for now. And I'm going to look at my other endpoint. I know that my endpoint is 7. And looking at my sign, I'm going to have an open circle. And I know that my y values are getting smaller than 7. So I'm going to shade this way. And so according to the arrows, I'm going to shade what's in between. And that's what my graph would be for my compound inequality. Now, remember how we talked about set builder notation in the last video, and our solution set would be with our curly brackets, define your variable, which is y, and we have our vertical bar, and we will just write our inequality the way we see it. 4 is less than or equal to y is less than 7. And there's your answer. Now it's your turn to try an example. Now we're going to move on to the or compound inequalities. Okay, so in this case, we have an example. We have x is greater than or equal to 5, or x can be less than -3. When you have something that's an or, you're going to have your two endpoints, and your arrows should be actually going in opposite directions. Okay, so a compound inequality containing the word or is true if one or more of the inequalities is true. So let's try an example. Example 2. Solve x plus 3 is less than 2, or negative x is less than or equal to -4. And then we're going to graph the solution set on a number line. So in this case, we're actually going to solve these separately. So I'm going to rewrite my inequalities and solve separately. So in the first one, I'm going to subtract 3 from both sides. And that's going to give me x is less than -1. On the other side, we have to divide by a -1, because technically, if there's not a coefficient in front of my x, we know that there's a 1. Well, since we're dividing by a negative, that means we're going to have to flip our inequality. And we're going to say x is greater than or equal to 4. Now we can graph our solution. Looking at the first inequality, we see x is strictly less than -1. So that means I'm going to have an open circle at -1, and we're going to be shading to the left. And if we look at x is greater than or equal to 4, that means we're going to have a closed circle at 4, and we're going to be shading to the right. Okay, so we shade to the right, and over here we shade to the left. And this is what it would look like on a single graph. Okay, so we have this inequality here and this inequality here. Now, for set builder notation, we would have our curly brackets, define your variable, in this case is x, vertical bar, x is less than -1, or x is greater than or equal to 4, close curly brackets. And there's your answer for example 2. Now it's your turn to try. Now for example 3. Solve 2 is greater than the absolute value of d. Graph the solution set on a number line. If we think back to absolute value means the distance from a point on a number line. So what we want is the distance from 0. Okay? So this means we want our distance to be less than 2 units from our 0. So let's take a look at a graph. So we have 0, 1, 2, 3, 4, and our negative numbers. Now, our starting point is going to be 0. Okay? The absolute value, or the distance, can only be less than, strictly less than 2 units to the left or the right of 0. Well, if we go to the right, we can only get to 2 units. And we know that needs to be an open circle because it is strictly less than. Okay? Now, we can also go to the left 2 units, and that's going to put us at negative 2. That is also going to be an open circle. Okay? So, our answer is going to be any value that's between negative 2 and 2, and that's going to make a distance that is less than 2 from 0. And the way we would actually write that solution set is our curly brackets, and in this case we're using D as our variable, our long bar, and we know that negative 2 is our first starting point. That's less than D, which is less than 2. I know that might be a little confusing, so let's try another example. Solve 3 is less than the absolute value of D. Graph the solution set on the number line. So let's think about this. 3 is less than the absolute value of D. That means the distance between D and 0 on a number line is greater than 3 units. And to make this true, you must substitute values in for D that are greater than 3 units from 0. So for instance, you can plug in 4, 5, 6, 7, so on and so forth. You can plug in negative 4, negative 5, negative 6, and the absolute value of those are still going to be a distance greater than 3. So let's go ahead and plug that on or draw that on a number line. Alright, so let's think about our endpoints. We look at our inequality, okay, and we're going to start at 3, and we want numbers that are greater than 3 because we want the distance between 0 and that number to be greater than 3. So we're actually going to shade to the right of 3. Okay? Now, let's think about it in the negative direction. Okay? So if we take the absolute value of 3, or absolute value of negative 3 is 3. Absolute value of negative 4 is 4. So that is actually a number that's bigger than 3, and it has a greater distance from 0. Okay, so this distance here is 4, and all we wanted for it to be is greater than 3. So this actually satisfies our condition as well. So we're going to shade all the way to the left. Okay. Now remember, when we had our endpoints and the arrows were pointing in opposite directions, that was an OR statement. Okay, so this is going to be an OR statement. Up above, this was an AND statement. Okay, because we actually shaded everything that was in between. Alright, for set builder notation, we're going to have our curly brackets. We're going to define our variable, in this case is D, vertical line. We're going to read from left to right. We have D is less than negative 3, or D is greater than positive 3. Close your curly brackets. Alright, now you try an example. Alright, moving on to the good stuff. Alright, an absolute value inequality can be solved by rewriting it as a compounded equality. Alright, so if you take a look at this first one, we have our inequality, and it's strictly greater than, and it could be equal to, than some number. If it's written like that, you can actually write it as an OR inequality, where you have the absolute value is greater than your number, or you have the absolute value is less than the opposite of your number. Now, this stuff can get kind of tedious, so make sure you're really looking over this and you're trying to soak it in, because it can get kind of confusing. And we'll do an example in just a second. Now, if you have your absolute value and it's less than your number, that means this can be written as an AND inequality. So you have the opposite of your number is less than your stuff on the inside of your absolute value is less than just your number. Okay? So let's try an example. That might be a little confusing, but it'll make more sense in a minute. Number 4, solve the absolute value of 2x minus 2 is greater than or equal to 4. Now, this actually follows the pattern of this first one we were talking about, and we could write it as an OR inequality. Alright, so I'm going to write this as two separate inequalities. I'm going to write the stuff in my absolute value, 2x minus 2, is greater than or equal to 4. So just like I see it. Now to solve the other piece, I'm going to write 2x minus 2. I'm going to flip the inequality sign to get is less than or equal to, and then I'm going to take the opposite of 4, which is negative 4. Now I have my two inequalities that I can solve separately. Over here I'm going to add 2 to both sides to where I get 2x is greater than or equal to 6. And then I'm going to divide both sides by 2 to get x is greater than or equal to 3. On the other side, I'm going to add 2 to both sides to get 2x is less than or equal to negative 2. And then I'm going to divide by 2 on both sides. Now, since I did not divide by a negative, I am not going to change the way my inequality looks. It's going to face the same way. So we have x is less than or equal to negative 1. So I'm going to graph my number line. I'm going to look at my endpoints. I know that I have a closed circle at 3, and I have a closed circle at negative 1, and then I need to think about my shading. If I look at this one, x is getting bigger than 3, so if I plug in numbers like 4, 5, 6, 7, those are all going to satisfy my first equation, so that means I'm going to shade to the right. And on the other side, I have x is less than or equal to negative 1. So those numbers would be like negative 2, negative 3, negative 4, so on and so forth. Those are smaller than negative 1. So I'm going to shade to the left of negative 1. And this would be the graph of my solution set. If you remember, when we have our OR, that means we're going to have our arrows going in opposite directions. Okay? And the self-builder notation for that would be curly brackets x, vertical bar, x is less than negative 1, or x is greater than or equal to 3. Now I'm going to have you try an example just like this one, and no worries, you'll get some time to practice in class with the other type. And that's the end of our tutorial. See you in the next video.